I think I'm recording, but it hasn't told me. It says we're recording now, so that's fantastic. All right, so welcome everybody. We're teaching Math 1060 Trigonometry. This can be a very difficult class, so I'm going to tell you guys all that I guess they kind of gave us the option to meet in person or online, and with the way the pandemic's going here in Utah, I had a feeling. Oh, we've got an unknown user. Unknown user, can you tell us your name?
Cameron Ravert.
Okay, good. I'm going to try to give extra credit for people who not only come to meet our online virtual class, but also get on camera so that we can see you. So unknown name isn't going to be, or unknown user is going to be very difficult for me to give you credit. So please, I guess you don't have to download the team software. If you do and you log in, then you don't have to put your name in every time. Makes it really easy. But yeah, so if you want extra credit, that's how we do that. So basically, I'm just going to give you basically 5 points a day. It's going to be extra credit, and at the end, you know, if you're here every day on time and you stay for the whole meeting, then they can give you up to 5% extra credit. So anyway, the reason why I want you guys on camera is sometimes I've noticed that people either walk away or they don't listen, and so it'll just kind of keep you guys on your toes a little bit better. And so I appreciate that. And this is going to be a very hard class, and so it's important that when you're here, you're focused and you're learning, and also that you can ask questions. So that's going to be a very important part of your success, is coming to class, even if it's in your car or in your home or wherever, or work or wherever you are. Although I hopefully don't want anybody driving while they're here. I've actually had that. I've taught an online class and people were driving, and I'm like, no, you don't get credit for driving. That's dangerous. So fantastic. It looks like we've gotten a lot more people here, so that's fantastic. So all right, so let's oh, I thought I had my syllabus pulled up here. Let me pull up my syllabus here really quickly, so you can see that here. I'm going to share my screen here. If I can get the thing up here that I want to. Okay, let me share. Okay, so here's our syllabus for the summer semester. Oh, I should actually point out that it's posted online on our thing here. So Math 1060, I posted this late last night. If you go over here to syllabus, and you've got your syllabus and your homework, maybe I should show you your homework. So I've got the homework for the entire semester posted here. Those are all the problems. This is roughly the order we'll go in. We're going to start on section 2.1, and I believe we're going to do that. And then notice we'll go over 1.6 a lot later. That kind of goes along better in that order. So, oh, it says summer 2013, but that's the current semester. All right. So I'm not going to read this. Let's see. So class is Monday through Thursday, 8 to 9:25. Oh, a.m. Sorry, not supposed to say a.m., not p.m. I've got a link to the room. This will be the same room we're going to meet in every day. If you need to get a hold of me for some reason, feel free to text me. There's my text number. I will also tell you, this is my email, but I don't check this very often. Just go ahead and use Canvas email. And if it's really important, go ahead and text me. we're going to be using the college trigonometry 6th edition by Elfman. Here, I'll give you a picture. I'll start unsharing here for a second. So you can see here is the book here. And we're going to go over this today. So we're not going to take that long on a syllabus, but this is it. So anyway, you'll want to get that today, absolutely, because we're gonna have a quiz tomorrow, and so we're not going to waste any time with this short class. Most of this work won't involve calculators. You will be required to use a simple calculator, non-graphing and non-programmable for some application problems. So we're going to have quizzes daily. They'll be due 5 minutes before class every day. At the beginning of class tomorrow, you can ask me, oh, I didn't know, I understand number 2 on the quiz. Quizzes shouldn't take more than 15 minutes probably, but those will be due before class. The one thing I've noticed with meeting in over Teams, it seems normally if we were meeting live, I'd do the quizzes in class and we just grade them immediately, but it seems like it takes me a lot longer to explain, and so that's why we've moved them just slightly outside of class. So exams, we're going to have exams every other Thursday. I guess, so there'll be 3 exams. Won't be one this Thursday, but next Thursday. Homework. So I haven't taught this class for a while, and I'm sure there's a homework. So that's going to be worth 5% of your grade. The only problem is I haven't been able to figure out how the online homework works. So today it'll just be kind of on your honor. I'll probably just ask you how much homework you did until I can figure out how to get the online homework. I've asked several teachers and nobody knows. So, but anyway, there will be a quiz tomorrow, and the quiz will assume you did your homework. So if you don't do your homework, you are absolutely going to struggle in this course. This is a very difficult course. So I've got your grading scale here. Exams 60%, quizzes will be 5%, homework will be 5%, final exam will be 30%. If I can't figure out how to do the online homework, I'll probably bump the quizzes up to 10%. So I've got a couple of emails out and hopefully they get back to me today. So important dates: July 8th is the last day to add, last day to withdraw, July 17th. Our final exam will be, oh, it says PM again. Sorry, this is AM. Will be 8 to 9:25 AM on August 13th. And you can read all that other stuff. It's really exciting. So just remember, we are not really going to be using calculators in this class. A lot of this math is going to be we're not going to use calculators, so that's going to be a small part. Do you guys have any questions for me?
Do you happen to have the ISBN number for the book?
Oh, yeah. Do you want me to read it to you?
Yes, please.
It seems ridiculously expensive. I was looking yesterday, because this is a 6th edition. It's a pretty old book. I was actually surprised we're still using this edition. And it was like, when I saw it yesterday on Amazon, it was like $270. I'm like, are you kidding me? So hopefully there's better places than Amazon to get this. But the ISBN 10 is 0-618-82507-X. I don't know if you need that X on there. And there's a 13 on there. Maybe I'll show that. Oh, except for I'll post that if you want. If you don't want to write that down, but yeah. Anyway.
I've got a question.
Say that again.
I've got a question. Kind of goes along. I just
Chris is talking, but he sounds like a robot. I can't tell what you're saying. I don't know if you've got bad internet.
Yeah. Let me see if I can
Chris, you may want to chat because your internet's so bad I can't tell what you're saying. Or if you want to write your question in the chat, I'll try. Anybody else have any questions while Chris is writing that? Or you can try it one more time, Chris. Your video looks fine, but your audio sounded terrible. Are you writing a note?
Yeah.
I heard the yeah. That was the best thing I'd heard. So unknown user, by the way, if you want credit, please tell me who you are. You ordered the book and it comes Wednesday. What do you do for the homework? Oh, good question. I understand. Maybe I can post the first thing on the first. Yeah, I'll try to post the homework for there. I will tell you, I believe the UVU library is open. They usually let you check out the book for like an hour at a time. So I don't know if that's an option. Obviously, they don't want the whole class doing that. Your book was on back order, but it should be here Wednesday. Okay, so Cam, same sort of a thing. I will try to post the first section's homework after class today, so that you can at least do that. So, any other questions? Alrighty, well, we're gonna get started on. Let me see if I can pull up my note. I'll try to post my lecture notes after class each day. I don't think this first section will be too bad. We'll see. All right, let me close some of this stuff. And let me start sharing again. Oh, there was a comment there. Actually, I didn't see the comment. I just saw it as I hear. Can you buy the books at Barnes and Noble? I have no idea. Probably. Well, probably the online site. So yeah, I don't know. There's a book. There was a website called ABE Books. That might have it, and sometimes that's a better price than like Amazon. That might be, but you know, if you're buying it online, it'll take you a few days to get here. Barnes and Noble didn't have it. Thanks, Cassie. Okay. All right, I'm gonna share again. Okay, so we're gonna cover section 2.1, which is angles and arcs. And so basically, we're going to be measuring our angles from the x-axis. So if you've got your x-axis, your y-axis, measuring it in this positive direction, or the blue line here, is a positive angle. Measuring it in the negative direction is a negative angle. Okay, so you can have either a positive or a negative angle, depending on which way you're measuring it. So a complementary angle, most of you should know this, adds up to 90 degrees. 90 degrees is known as a right angle. Okay, so I've tried to underline vocabulary words that you're going to want to pay attention to. So we've got right angles, complementary angles. Those should be pretty obvious by now. You've probably used those in a lot of other classes. Supplementary angles add up to 180 degrees. 180 degrees is also known as the straight angle. So if we wanted to use this little graph here, If we're measuring it in this direction, that would be a positive 180 degrees. Or if we're measuring it from the bottom side, this would be a negative 180 degrees, also known as the straight angle. If we want to get more accurate, we can divide the degrees into minutes and seconds. So you'll hear this a lot of times with like Navy shows, they'll talk about 36 degrees, 13 minutes, 45 seconds. And basically that's going to be, you get the little kind of a circle there for the degrees, and then you have like an apostrophe for your minutes, and then a double quote for your seconds. So that would be 36 degrees, and then 13 over 60 minutes, and 45 over 3600 seconds. So that's how that works. So this second number is divided by 60. The third number is divided by 3600. All right. So angles between 0 and 90 degrees are acute angles. Angles 90 to 180 degrees are obtuse. So once again, we've got the initial side. If you're measuring it from the x axis, then this would be a negative angle. This would be a positive angle. Do I have? Now I will warn you, when I'm sharing my screen, I can't see your chat, and I have to unshare in order to see it. Oh, somebody just said that you can rent it for 20 bucks on Amazon. Is that, Chris, since you mentioned that, is that, that must be an online version of the book, or just a PDF kind of a thing? Do you know?
Hardback.
It's a hardback?
Yeah, I'm getting it Wednesday.
Oh, good. Okay, you're getting it Wednesday. Yeah, with the free day, 2-day shipping. Okay, good to know. All right. So let me just see here. All right, so I'm sharing my screen again. So yeah, if you can speak up, even if it's terrible, I'll try to, I can't monitor the chat while I'm sharing my screen, but. All right, so some other terms that we need to know is coterminal angles. Those are multiples of 360 degrees. Think of a snowboarder who does a 720 degree flip. So that would be an example of a coterminal angle. Also, the angles 90, 180, and 270 angles, or 70 degrees, are known as quadrantal angles. So that's another term that you'll want to pay attention to. Now, another way to measure, in fact, this will probably be the first class that we've ever measured this in, is in radians. And so the circumference of a circle is 2 pi r. So if the radius of a circle is 1, we're going to call that the unit circle. And we're going to use the unit circle a lot in this class. Therefore, pi equals 180 degrees. And we refer to this as radians. Radians can be thought of as unitless. And sometimes using radians, it makes our math a lot easier. So radians can be useful in finding the length of an arc. And so, so if we remember that, so pi is 180 degrees, we can convert. Now I'm going to use Excel here because I think it's easier to see than my handwriting. So one way to think of this is if we're going to convert 60, and I'm going to put the degrees here. If you pay attention to the degrees, and then you can know where to put the. So if I put degrees on the denominator, and we know that 180 degrees equals pi radians. Okay, so now you can see, I'll highlight those. Those will cancel each other. And so what you can do is, so 60 goes into 180, 6 times 3 is 18. So basically this becomes pi divided by 3 radians. Okay. And so, so that's how we will do those. So you guys have kind of, if you see this as, so I would prefer that you would leave this as a fraction. I'll try to make that look a little bit like a fraction. So pi over, so 60 degrees would be the same thing as pi over 3 radians. You don't need to necessarily put radians there. So that will be an example here. This is pi divided by 3 radians. So just because I want to get you guys involved, I'm going to start picking on people. Maybe we'll pick on people at the back here. Unknown user, if you can unmute yourself and tell me your name so that I can give you credit for being here. This is your extra credit for showing up today. Can you tell us your name, and then after that, can you convert, or tell me how to convert 315 degrees to radians? Now, you're still muted. It's another reason why I like you guys on camera, because then I can tell if you've walked away from your computer or not. So unknown user, you might not get credit today. All right, we'll skip unknown user. I don't know who that is, clearly. How about Texas? Can you tell me how to convert 315 degrees to radians?
Wouldn't you divide 315 by 180 and then get 1.75 radians?
Okay, so you did it that way. Okay, yeah, so basically the same thing. So 315 degrees, we're going to use the same thing, pi over 180 degrees. So those will cancel.
Yeah.
So yeah, so 315 divided by 180, that one's not as easy, is it? So the 315 divided by 180, so that's going to be 1.75 times pi. So don't forget the pi in there. So that will be, yeah, 1.75 pi. So we could do that one if you want to call that 1.75, and I don't know how to make pi, so I'm just going to put pi for pi. Okay. So well done. It looks like Texas knows what he's doing. How about another one? Let's pick on somebody else. We're going to do negative 150 degrees. We want you to convert that to radians. Samantha, can you help us do that?
Yeah. So what you would do is pretty much just divide it by 180 again.
Okay. All right. So negative 150 degrees and 180 degrees. Now the question is, can you convert this? So this is a good one. I'd like you to leave these as fractions as much as possible. So, let's see, 15. So both of these are divisible by 3. So that would be 5 over 6, right? And it's a negative 5 over 6 times pi. Does that make sense? I'll try to make that look like a fraction. So when we're doing this, if this were a quiz question, I would want you to write this as negative 5/6 times pi. Or better yet, just to be clear, negative 5 pi over 6 would even be better. Does that make sense? So that we're not, so leave the pi in there as we're doing this. Now let's see how we can do here. That was Samantha. Nicole, can you help me convert 3 pi over 4 radians to degrees?
So that's a good question. So it'd be 180. Would you convert that to radians? Or do you leave it in pi, since the 3 pi over 4 is already in radians?
So we've got a 3 pi over 4 is already in radians.
Okay.
And so now the question is, do I divide by 180 or do I multiply by 180?
Oh. would you multiply? I'm not totally sure, I'll be honest.
Yeah, okay. So in this case, realize the way that we've done this before, remember pi over 180 represents the number 1 in all three cases that we did before. So
Okay.
now we're going to put the pi on the bottom because we want the pi's to cancel and we want the 180 degrees
Okay.
to be on top. So now in this case, the pi's cancel. Now this is still in the way. So my pi's cancel. 4 goes into 180. Those are both divisible by 2. So this would be good. So I'm going to change that to 3 over 2 and then 90. And then the 2 goes into 90 evenly. So this becomes 3 over 2. 3, oh, no, the 2 goes away. 3 times 45. And then, let's see, 45 times 2 is 90. Yes, this is going to be 135.
Okay.
So this is 135 degrees. Okay.
Okay, thank you.
Does that make sense?
Yeah, that does.
Okay, perfect. So, so this becomes 135 degrees. Okay. Let's convert 1 radian to degrees. So now, let's see, who did I just pick on? That was Nicole, wasn't it? Okay. Mason, can you help me convert 1 radian to degrees?
I can sure try. So wouldn't you want to do the opposite of what we just did? When you want to divide, or I guess you, I'm not totally sure, to be honest.
Okay, so we're going to use this same ratio. It's either going to be 180 over pi or it's going to be pi over 180. So which do you think we would use in this case?
It'd be the opposite of what we just did, right? So pi over 180.
Oh, it would be the same as what we just did. It would be 180 over pi.
Okay.
Okay, because remember, you can think of pi as radians.
Right.
Now, we don't usually put radians in here, but in this case, if you keep track of your units and then you treat this as a fraction, the radians will cancel.
Gotcha.
And so in this case, now we can just multiply numerators and denominators. So what do we have here?
You just have 180 right there.
180 over
pi.
pi. Okay. And so this is exactly how I would want you guys to write it. If this was a quiz question tomorrow, I want you to write this as 180 divided by pi. And if you want to use pi for pi because you're typing it in or something, that would be great. Although, yeah. I probably will have some multiple choice on the quiz because it'll just make it a lot easier to grade. But if I ask you a short answer, 180 divided by pi would be great. Okay, so now let's do negative 5 pi over 2 radians. And I can't remember who I picked on. That was Mason. Jackson, can you help me convert, I already forgot what I said, negative 5 pi over 2 radians. And we don't, honestly, we usually don't put the word radians here. I'm putting it there just to make it a little bit easier for you guys. Negative 5 pi over 2 radians. Normally we wouldn't put the radians there, but sometimes that can be helpful, especially when you're learning how to do this for the first time. I already forgot who I picked on. Who was it? It was Jackson. Okay.
Yeah, it's me.
Okay.
So
how do you do that?
you would divide by pi and multiply by 180, and the pi's would cancel nicely.
Mm-hmm.
And then you'll just have 90 times negative 5.
Yep, perfect. 90 times negative 5, and do you know what that is?
No.
9 times 5 is 45. So this would be negative 450, and that'll be degrees. Okay. And I know, especially if this is a quiz question or a test question, make sure it's probably hard to do that little circle. I've got it on my spreadsheet here. So this is negative 450. If you want to write in the word degrees, that's fine. Or I don't know how to make that circle. That's going to be way too hard. So, so just remember that for the quiz tomorrow. And I haven't made the quiz yet, so I will do that right after class today. All right.
I have a question about that one you just did.
Okay, go ahead.
Do you do anything with the 2? Like, would you divide it by 2 or anything? Or
Yeah, we did do it. So remember, the
did divide
2
by
goes
2.
into the 180. 2 times 90 is 180.
Oh, okay. Sorry.
And so then that's why that turned into a 90. So 90 times 5 is 450.
Oh, okay. Awesome. Thank you.
Yeah, good question. All right. So so remember, and just to remind you, we are going to expect that you're not using a calculator for most of these. I think I used it for the one because I wasn't sure, the 1.75, the 315. But yeah, you probably should get used to not using a calculator on these kinds of problems other than that. So I don't know if you've had a lot of math classes with Greek letters. We're going to teach you a lot of Greek in this class. So this here is the letter theta, okay? And so a lot of times we'll want to know the length of an arc. So this is a formula you're going to want to memorize for the test. Your arc length S equals theta R, okay? So the question is, how long is a 120-degree arc of a circle with a radius of 10 centimeters, okay? So if I go back to here, this is probably the easier. So if this represents a circle and I drew just a part of a circle here, I want to know how long this length is given this angle, okay? So going back to here, how long is a 120-degree arc? So that's going to be an obtuse angle of a circle with a radius 10. So we're first going to convert, and this is where you're going to find, so for finding arc length, we're going to prefer that we're in radians. So first thing is we're going to do is we're going to convert 120 degrees to radians just to make sure. So we want 120 degrees, and we've got a 10, did I say it was 10 centimeters? 10 centimeter radius. So who was the last person I picked on? I think it was Jackson. Graham, can you tell me how to convert 120 degrees to radians first, and then we'll figure out how long this arc length is.
Okay, so you set it up where 120 degrees equals pi over 180 degrees, right?
Over 180, and so now we're going to try to use our math here. Those are both divisible by 60, right?
Mm-hmm.
So 120 divided by 60 is
2.
2, and 80 divided by 180 divided by 60 is
3.
3. So we've got 2/3 pi here. Okay, so we've just converted that to radians, and now we can use our new fancy dancy formula here. Arc length is the letter S in the formula. Okay, so we've converted our 120 degrees to 2 pi over 3 radians, and now we just need to multiply that by R, and R is what again? Our radius.
Yeah.
Right, Graham?
Yeah, sorry.
So we're going to just multiply this by 10, right?
Yes.
So this becomes what? What's the arc length?
20 over, it wouldn't be 20 over 30, would it?
20 over 3 times pi. Don't forget the pi. Pi is very important.
Okay.
Okay. So we'll treat that as a fraction, and that's your answer. So that's the answer I'm looking for. 20 pi over 3. If you want to probably, okay, so yeah, so 20 pi over 3 centimeters. Now, if you want to convert that to actual centimeters, if I took 20 times pi divided by 3, that's going to work out to be about almost 21 centimeters long. But I'm much happier with 20 pi over 3 centimeters as your answer. So that's the answer I'm looking for there. Okay. All right. A 10-inch pulley drives a 10-inch pulley drives a 6-inch pulley by a belt. If the 10-inch pulley makes 1 revolution, what angle is made by the 6-inch pulley? So the idea here is, let's see if I can use this here. Just so sometimes you'll have, so we'll say that this is our 10-inch pulley. So, ooh, that's a terrible straight line. Let's try that again. We'll make it a straight line here. So if this is 10 inches, and inches, and then if I have a second pulley that's only 6 inches, I don't think I can draw an oval very well. Okay, so there's my 6-inch pulley. Okay, so the idea is, let's pretend I have a belt that goes around these things. I'm going to pretend, make this look like it's a belt that goes around and a belt that goes around here. Okay, so if this does 1 revolution, then this is going to do more than 1 revolution, correct? Okay, so that's kind of what we're doing. So the idea here is, we're going to use our arc length formula, S equals theta r, okay? So we're going to find the length of the 10-inch pulley. So in this case, your arc length is going to be 2 pi, because 1 revolution, open up a new page here. So 1 revolution is going to equal 2 pi. Okay, so this top pulley here, this top pulley is going to make 1 revolution, so it's going to go 2 pi, and then times your radius, which is 10 inches. So that's going to go 20 pi. Okay. So remember here, as we're looking at our pulley here, this also has to go 20 pi radians, but it's a smaller radius. Okay. So in this case, you can set the 20 pi for the bigger pulley equal to pi times equal to your theta. So your theta is going to be 20 pi, but your radius is only going to be 6 inches. Okay. And so in this case, you're going to convert that to, so that's going to be 10 pi over, so your angle is going to be 10 pi over 3. We're going to convert that to basically to 600 degrees. Okay. So does that make sense, what we've done there?
Makes sense to me.
Okay. All right. So so that's going to be a good homework question probably. Okay, so let's talk about linear speed. Okay. Linear speed is a point on a circular path of radius r, and it goes at a constant rate of theta radians per unit of time t. So your velocity is given by s over t, where s is your arc length and t is your time. Okay, so that's actually, I probably should highlight it here. That's another formula that you're going to want to know for this section. So remember, your angular speed, where s is your arc length equals theta r, is a point angular speed given by, and it looks like a W, but that's actually the Greek letter omega. So omega equals theta over time. So that will be another formula that you're going to want to remember for the test. Okay. And I know we're going to give you a lot of formulas. The math department has asked that you memorize all of these. So we're going to have a formula sheet for these. And so make sure you know these really well. Okay. So in this case, we're going to do an example of a hard drive. It rotates at 3,600 revolutions per minute. We need to find the angular speed in radians per second. Okay. So basically, okay. So by the way, a hard drive, most of them go twice that speed. Most of them go 7,200, and you even have some that are 10,000 revolutions per minute. So this is a very slow hard drive. It must be back in the old days. Okay, so we're going to use the same sort of a thing. So you're going to convert everything to a fraction. So we've got 3,600 revolutions per minute. So treat that just as a fraction, revolutions per minute. Now we need to cancel the revolutions. So we're going to put so keep track of your units. We want the revolutions to cancel. So revolution is going to go on the bottom, and we're going to have 2 pi radians on the top. Okay. So we've just, in fact, that really shouldn't be, well, this really should be a multiply. I'm going to modify my notes here. Okay. So we've got revolutions per minute, and we know that 1 minute equals 60 seconds. So really, I'm just multiplying this by 1. So now this minute cancels that minute, and this revolution cancels that revolution. So I've now converted revolutions per minute to radians per second. Okay, and that's what we want, is radians per second. Okay, and so 60 goes into 60 times 60 is 3,600. So now I've got 60 times 2 pi equals 120 pi radians per second. And if you plug that in your calculator, you're going to get 377 radians per second. Okay, so that's what we would call the angular speed in radians per second. Okay, so angular speed, once again, that's represented by the letter omega, and that's going to be your angle, which is 377 radians per unit of time, and in this case, we're using seconds. So does that make sense to everybody? Okay. I'll try to pause and let you guys ask me any questions. Okay, so let's do another example. This time well, maybe, let's see, do I want to keep this? I'm going to copy this so you can look at this as an example here. Okay, so that's the example we just did. What I want to do is I'm going to have somebody help me solve this one. So a windmill has 12-foot long blades. If it runs at 3 revolutions per second, what is the linear speed at the tip of the blades? So this time I'm going to pick on Chris. Chris, hopefully you don't sound like a robot. How would you help me solve this one?
So let's see. I do 3 revolutions over seconds. Revolution.
Okay.
And then I do multiply by 2 pi radians over revolutions.
Okay, so now the revolutions cancel, so good job.
Okay, and then I need to cancel. Do I need to cancel out the seconds? Or do I just do the same 1 minute over 60 seconds?
We want the linear speed on tip. So yeah, we can leave it in seconds. We don't need to convert the seconds.
Okay. So I don't know what to do after that.
So what?
I don't know what to do after that.
At this point, we've got our angle, right? So this becomes 6 pi. And we don't really need to put radians on this yet per second, but we've got the angular speed, right?
All right.
Okay, so we're good there. Okay, so now linear speed can be given by this. So let me copy this here. So linear speed velocity can be given by radius times your omega. Okay.
Okay.
So what is? I'm going to put this over here. Okay, so this is our formula that we're going to use. So we're going to so we've got. So this represents what letter in that formula?
That's the angular, so that would be the omega, right?
That's the omega. Correct. Okay, the weird looking W in there.
Yeah.
So now what do I have to do to get the angular velocity?
So then multiply that by 12.
Yeah, so that's the radius of the windmill, right? So 12. Yeah. So 6 times 12 is, do you know that one off the top of your head, please?
That is 72.
Okay. Pi over, let's see. Yeah. So, yes, so 72 pi feet per second. So these are feet. We need our feet in here per second. Okay. So the tip of the blades are going at 72 pi feet. And if we multiply 72 times pi, that works out to be 226 feet per second. So that's what that's how fast the tip of the blades would be going. Okay.
Okay.
Now, we're probably going to leave this as 72 pi feet per second. I know a lot of us think in feet and we don't think in pi. But that's, so 72 pi feet per second, which is about 226 feet per second.
Okay.
Gosh, we are cruising. I didn't think we would get through this much information this quickly. Because that's all I had for section 2.1, and we've still got 40 minutes left. I'm trying to decide if we should go, I guess we should go over another section. The nice thing is when we go fast over the easy stuff, then we can slow down for the hard stuff. So I heard a beep. Did somebody just join and needs me to enter? Let's see here. Oh, I don't know what that beep was. Somebody, it must be Kobe Escalante. Were you the unknown person, Kobe? Because you look like you're new. Okay. I don't know. All right. We really got through a lot faster than I expected. I guess we could go over the next section. Do you guys want to do that?
Sure.
Yeah, let's do it.
All right. I really didn't think we would get through as fast as we did. Go ahead, question?
Yeah. You said you're gonna upload your notes after the lecture.
Right.
Yep. Okay. I just want to make sure. Thank you.
Okay. All right. Let me find section 2. Okay. I wonder if we're going to cover 2 whole sections today. We'll find out. Okay, so let me share my screen here. Okay, so section 2.2 deals with right triangle trigonometry. So the idea here is, and by the way, I should mention this, trigonometry, you probably wondered where that name comes from. And so we can think of trigonometry, in fact, here, I'm going to add this in here. a trigon, right? A trigon is a three-sided polygon, right? Okay. Now, we normally call it a triangle, but that's where we get this. So trigonometry would be the study of trigons or triangles, okay? So so we're going to be using a lot of triangles. We're also going to be using a lot of unit circles. So you'll definitely want to keep track of that. So let's talk about, so the idea here, the angle, so this angle here is going to be, if we have a right triangle, so I've got a 90-degree right triangle here. So this angle here is going to be the length of the opposite side, this length here, divided by the hypotenuse, okay? The cosine is going to be the adjacent side, so this side next to the angle, divided by the hypotenuse. And so you can see here, the cosine of the angle is going to be the angle, the adjacent angle divided by the hypotenuse. So this is something you're definitely going to want to memorize. Your tangent of the angle is going to be the ratio of the opposite side divided by the adjacent side, okay? And so these three here in this column, you'll definitely want to remember that. Now, the other thing that you can remember is these are known as reciprocal functions, okay? So the cosecant, maybe I should spell that out, cosecant, okay? It's abbreviated as CSC. So the cosecant is 1 over the sine. So another way to think about the cosecant would be the hypotenuse over the opposite. The secant, S-E-C-A-N-T, secant is abbreviated as SEC. So secant of theta is 1 over the cosine. Another way to think about that would be to do the hypotenuse over the adjacent. And then the cotangent, C-O-T, cotangent, tangent. Okay. Abbreviated COT is 1 over the tangent. Now, mostly people usually memorize this one, and this one, and then you just know that these are the reciprocal functions. So I remember when I took trig, I just memorized basically this left column, and then I remembered that these are just reciprocals of those, okay? So now we have what's known as the 3, 4, 5 right triangle, okay? And so this is a fantastic triangle, okay? So the sine is going to be your opposite over your hypotenuse. So in this case, if this is my angle theta, then the sine of theta is going to be 3 divided by 5. Your cosine is going to be your adjacent divided by your hypotenuse, so that's going to be 4 divided by 5. And your tangent is going to be the opposite over the adjacent, so that's going to be 3 divided by 4. So once we have the left side here, the right side is easy because it's just the reciprocal. So the cosecant is the reciprocal of the sine, so that's going to be 5 over 3. The secant of theta is going to be the reciprocal of the cosine, which is 5 over 4. And then the cotangent is the reciprocal of the tangent, which is going to be 4/3. Okay? All right. So given that an angle theta, that theta is an acute angle, okay, and the cosine of theta is 8 over 5, find the tangent of theta. So one of the easiest things to do as we're doing this is to go ahead and draw a triangle here, okay? So this is your right triangle. And I've got a right angle here. Obviously I didn't draw that very well, but it's a right triangle. Okay, So if we refer to this as our angle, and I don't know how to draw Greek letters very well, so I'm just going to call this theta. Okay. And we know that the cosine of theta equals 8/5. Okay. So we're going to use that information. And now, let's see, whose turn is it? I think it must be Kobe. Kobe, are you on? It looks like you unmuted yourself. Can you hear me, Kobe? Because I cannot hear you. Kobe, we can't hear you. Okay, hopefully you can get that mic. How about Cameron? Can you hear us, Cameron?
Yeah,
Yeah, I
I
can
can.
hear you.
Oh, good. There's Cameron. Oh, there's two Is there two Camerons? There's a Cameron with a C and a Cameron with a K. Cameron with a K, can you hear me?
Yeah, I can.
Oh, okay. So Cameron with a K. So how would you label, hopefully you've memorized your cosine, how would you label this right triangle?
So it would be that top right side. Wouldn't that be 8? And then, oh wait, no,
Let's
that's
back-
adjacent.
That's
Right?
exactly right. Yeah, so cosine is your adjacent.
Yeah,
So this one's going to be 8, right?
yeah. And then,
And this is your hypotenuse, which is
that 5, right?
5. Okay. So how would we figure out what this side was?
Wouldn't you do cosine 8 divided by 5 to figure that out?
How is your hypotenuse longer than any of the other side? Or how is it shorter than if it's 5?
That's a good
Isn't the
question.
hypotenuse the longest side?
That is correct. So we mislabeled this, didn't we? So let's try that again. In fact, let's pull out our definitions here so that we've got them here. So remember, yeah, we definitely labeled that wrong. Sorry. Well, I didn't mean to. Oh, it doesn't like that. It's fine. Okay, I didn't. Here, we're going to copy these over here. So let's remember. Let's remember these things. Obviously, we can ignore that. In fact, maybe I'll get rid of that in a second. Yes, we definitely mislabeled our thing. Okay. So remember this. So we've got the cosine here is 8/5. So in this case, it's the adjacent. Oh, it does say that. Oh, that's a typo. Okay. I guess I got to fix my notes. That's obviously, so Cameron did it correctly, but, and I don't know who it was that pointed out, that was Tayton, wasn't it? So good job, Tayton. So clearly this relationship can't exist because the hypotenuse has to be the longest side. So that was my typo on my notes, which I didn't notice till Tayton mentioned that. Okay, so if this is 5/8, let's try that again. So therefore, this has to be 8, this has to be 5. So Cameron with a K, trying to remember what my question was supposed to be. Find the tangent. So we need to find the tangent. Find tangent of theta. So tangent is opposite over adjacent, right? So we've got to figure out what is this side. So how would you figure out that side there? Any ideas? Do we take that as a no?
Well, if you know the angle of theta, wouldn't you be able to figure out the length of the opposite side?
And how would we do that?
So you would take the tangent of theta and set that equal to whatever that number is, in the question mark over 5.
Okay, so question mark divided by 5.
Yep.
Okay. Now that's good. So you're using the formula here. That's good. Now the question is, how do we find out what the question mark is?
Do you use is it called Pythagorean Theorem?
That was very good, GJ. That was Graham. All right, good. Okay, so so we can use the Pythagorean theorem, right? So what's the Pythagorean theorem say?
A squared plus b squared equals c squared.
B squared equals c squared. Okay, so perfect. So let's plug it in.
So I get 5 squared plus the question mark squared equals 8 squared.
Okay, we'll leave the question mark as b. B squared equals 8 squared.
Correct.
Okay. So 5 squared is
25.
25 plus b squared equals, what's 8 squared?
76, I believe.
No, it's only 64.
64, sorry, my bad.
Boy, this is going to be a hard class without a calculator, isn't it? Okay, and then what?
Subtract 25 from 64.
Okay, so we'll subtract 25 from 64, so we're going to get b squared equals 25 minus, or 64 minus 24 would be 40, so 39.
And then take the
And
square
so-
root of both sides.
So b is going to equal the square root of 39. Okay, and since we're practicing not using a calculator, we won't figure out what that is. But we do know that this question mark now equals the square root of 39. And so now we can say that the tangent of theta equals what?
Square root of 39 over 5.
Divided by 5. Okay, so we've just figured that out. Okay, so that wasn't too bad, was it? Oh, we can close those notes.
It's much easier than I thought it would be.
Yeah, it's not too bad. Who needs a calculator? Okay. All right, so yeah, so tangent of theta equals the square root of 39 over 5. Okay. Now, some triangles that we're going to want to pay attention to. So your general right triangle, so the 3, 4, 5 triangle is really nice because you can figure out all of these relationships really nice. We also have the general right triangle, which is going to be side A, side B, and so your C is going to be your square root of A squared plus B squared, okay? We're going to have an isosceles right triangle. So if both sides are the same, and not then in fact, if we make both legs one unit, then that's an isosceles right triangle. These are both the same, and then you're using the Pythagorean theorem, you could know that your hypotenuse was the square root of 2. Because it's isosceles, you know that both of these angles are going to be 45. And so that's useful. We also have the 30, 60, 90 triangle. Okay. Now, the nice thing about the 30, 60, 90 triangle Okay, so the 30-degree angle is going to have your shortest side. So if we make that 1 unit, then your hypothesis is 2 units, and your adjacent leg is the square root of 3. Okay, and so so those are the 3 main triangles that we're going to be paying attention to. So the idea with an isosceles right triangle, it can be very useful. You can rationalize the denominator to get the values below. So we know that your angles are 45, 45, and 90. Now,
Did it freeze, or is it just me?
I think it's frozen for me too, man.
Yeah, me too.
Texas, you think you can teach us this lesson?
I know, like, what I've learned is from Khan Academy, so
Yeah.
I didn't know about the Radians part. So that was something new. Let me pull up what I had.
It doesn't even look like he's in the chat anymore. It says that he's not even in the meeting. So
if I had like this, the same stuff as him, then I can probably go on. But I mean, let's see.
oh, there you go. He's joining again.
Oh, there we go.
so I'm gonna, you know what? My power just went out. You can see my lights are out. That's what happened. So it killed my internet. I'm using my cell phone, but I don't have a lot of data on it. So I'm going to end class now. So I apologize for that. I just remembered that I forgot that the power company told me this is a planned outage at 9 a.m. And of course I was like, oh, not on the first day of school. So we're going to end class now because I don't have much time on my data. So quiz tomorrow is going to be on 2.1, and I'll probably just what we've gone over up to now is where we'll stop. So sine, cosine, tangent, that kind of a thing, and then we'll continue on tomorrow with 2.2. And so I apologize for losing my power, and glad I have a hot spot. So any questions before I let you guys go?
Is the homework
Yes.
posted on Canvas? Oh, sorry.
That was my same question.
So the homework, I haven't figured out how to do online homework yet. So I will, well, and I can't make a copy now because my power's out. As soon as my power comes back on, which is supposedly in about an hour, I will make a copy of the homework that you guys are expected to do. And I will post that on Canvas. And so you don't have to turn it in because I don't know how to make you turn it in. But it will be, the quiz will be very similar to the homework. So so today will be an on your honor thing, and then I'll probably just ask you how much homework did you complete, 100, 75, 50, 25, or 0%. And so that will be your homework grade for tomorrow. You can just tell me how much homework you did. Any other questions?
The quiz will be on Canvas as well?
Quiz will be on Canvas, yeah. So it will be up later today. I will try. Hopefully my power comes back on soon. So yeah, so the quiz will be. So the quizzes are going to be due 5 minutes before class, so you can see your answers, and then you can ask me about any quiz or homework questions. We'll cover that for the first 15-20 minutes of class tomorrow. So
So for
Anything
the quiz
else?
then, are we submitting that online on Canvas?
So the quiz will be online. Yeah, it'll be an online quiz. Yeah, just in Canvas. So just log on later today after my power's up. There'll be a quiz there.
Okay.
Or or you can take it if you want to get up early tomorrow. You can take it before class tomorrow. All right. Anything else?
No, thank you.
All right. Thanks. I'm sorry I lost power.
Have a good one.
You too. We'll see you.
All right. Bye.